Um, this is our sponsor, Alex Chen. He's going to be representing Gather, which you've all have used for Milestone 1. Alex has been on staff the last 3 years, so he's an old staff member. He was my TA when I took it as a freshman, and then we worked at Gather together. But he's very excited to teach you all about games. So if you're building a real-time game, you should pay attention because this will be very helpful. Yeah, Alex, take it away.
All right, thanks, Shannon. Hey guys, it's great to be back at Web Lab. This is a super awesome class, and I really miss it. So I'm glad you guys are having a fun time. But yeah, like Shannon said, today we're going to be covering a little bit about game development. I'm going to share my screen, and then we can kind of go from there. Hey, can everybody see that? Yeah. Yeah. Cool. All right. Awesome. All right. So just a quick kind of primer here. I'm sure you guys have all played Among Us, right? This is kind of the sensation that has swept the nation and also was part of this year's Web Lab video. But you know, a lot of other games exist as well, like we've seen, like Minecraft, League of Legends, even Gather could be considered a game. So all these kinds of platforms are called games, but you might wonder like, okay, these are so different from what we've been learning in Web Lab so far, right? Because everything we've learned in Web Lab so far is like, you have cat book, you know, it's like a feed, and then you have like profiles and stuff. And games are just so much more complicated. But to be honest, I think a lot of what you guys have learned so far really is pertinent to games. And there's only some small things that we have to add on top to really, you know, make your games really good. So today we're going to be talking about that. And in particular, it's going to be a very, very, very brief TLDR because you could learn a lot about games over, you know, many, many weeks, and we don't have time to cover a lot of that. So we're going to be trying to, you know, take the essence of game development and what you should watch out for when you're building your own games and kind of squash that into an hour, right? So we're going to be glossing over a lot of things. There's going to be a lot of skipping and kind of mushing over some concepts, but I'll be available afterwards to answer questions, and there's always Piazza with your wonderful staff. So let's get started. And I'm going to open up chat here so that I can make sure I can answer any questions you have. All right, sweet. So let's talk about games. So what really makes these real-time games so much different from Catbook, right? Well, the first thing is that there's a lot of really complicated logic that goes into games, right? So for Among Us, for example, you have, you know, who's doing what task, who killed whom, who's an imposter, who's not an imposter, which location you're in, all this stuff, right? And games also have a ton of really performance needed graphics, especially some games that are like real time, such as you can see here, League of Legends, right? There's all kinds of random nonsense going on. How do you render all of this, and how do you make sure your computer doesn't crash because, you know, you don't want to have to make all your users buy super powerful computers just to play your game, right? So these two are the pillar stones on which we kind of say games are a little bit different than what you guys have been learning so far. And we'll be diving a little bit into these today. Great. So let's talk about a little bit about what you guys have learned so far. Right. So this is kind of a diagram that might be a little bit familiar to you. Right. So you have a user, and it authenticates with some backend, which is your Node.js server in this case, right? And then I think Web Lab, we've been teaching you guys MongoDB as your database that backs up all the backend. So that's all good and dandy, but what do we have on top of that to support our games? Well, there's game logic and game state. And this game logic and game state lives in the backend. So it's going to hang out with all the other stuff that you've been writing for your API and things like that, right? And most importantly, that I want to emphasize is that game logic and your game state need to live in your backend, okay? They cannot live in your client. So if you're going to take something away from today and our discussion that we're going to have, is that if you're writing a game and you have logic, all right, it needs to go in your backend, okay? And the reason that is because if your game logic and state is held in the client, that's on everybody's computers, right? So if you have 100 people in your game, then you have 100 versions of what's going on in your game. And that's super not chill because everybody kind of needs to see the same state in order to play the game together, right? This would be the equivalent of if you're playing a board game and everybody has their own board. and then they have to like move their own pieces on their own board every time something happens. That just doesn't really work, right? So we need some central place where all this logic and state lives, and that's going to be our backend. Right? And second, we could talk a little bit about graphics here. So as you guys saw on that earlier slide, right? Some games are very, very performance intensive. There's all kinds of stuff going on. How are we going to draw that, right? How are we going to make sure all of that is being rendered to the screen so users can see it? Well, in our case, we're going to be using something called HTML Canvas. And I think you guys might have talked a little bit about it on one of the other sponsor lectures, but we're going to dive a little bit deeper into exactly what HTML Canvas is and give you a brief overview. So what really is HTML Canvas? Well, if you dive into it, an HTML Canvas is essentially just any other HTML element. So you guys learned about like divs and stuff like that, right? An HTML Canvas is just another one of those elements, except it has a special property that you can call this canvas and draw things on top of it. Like you can draw shapes, you can draw letters, you can draw images, right? You can draw whatever you want. And it's really, really fast at drawing these things. Super duper fast, right? And then if you draw really, really fast many times in a row, it can start to look like whatever you're drawing is like animating, right? So as you can see here, this ball kind of looks like it's like moving, right? But really what it's doing is Canvas is just redrawing over and over and over and over again until it looks like it's smooth, right? And this is not really something you do with React. React is like very static, right? When you update something, things change. But if you're going to update the React like 60 times per second or something like that, it's not going to be a great time. It's not going to be a great time. Right? So we normally would like to use Canvas for these kinds of renderings just because it's more efficient. And that's what we're going to use today. Cool. So diving a little bit deeper into this, you guys are probably familiar with this like XY coordinate plane, right? That you guys learned in like middle school or 7th or 8th grade or whatever. But in Canvas world, it actually looks a little bit different. So this is what your coordinate plane looks like on Canvas. So the top left is 0, 0 instead of the middle. And this is kind of weird for games because, you know, this means that if you increase your Y, you're moving downwards, right? Whereas most people would think of like, okay, if you're increasing your Y, you're going to move up, right? And we'll see later how we deal with that. But this is important to keep in mind because if you guys are ever using Canvas in your own games to draw things and you're like, everything's inverted, what's going on? I don't know. It's because 0, 0 is on the top left. So if you guys are drawing, you have to keep this in mind, okay? Great. So this kind of gives us the intro into the technologies we're going to be using today. Let's take a look at actually what we're going to be building during this workshop together. So here's kind of what we're going to be building. You can see it's a little fun, super fun game where you and everybody else in the same game as you guys are all little circles. And what happens here is you're trying to find the hidden spot in the world that is like the goal spot. So there's like this hidden spot that everybody's looking for called the secret spot. And every single circle is just like looking for that spot. So you're using your arrow keys to navigate around to find it. And the closer you are to the spot, the more blue your color is. And the further away you are, the more red your color is. So it's kind of like, you know, that hot and cold game you guys played when you were kids, except on the internet, right? So let's watch it one more time. You can see as you get closer to the actual spot itself, the color of your circle gets more and more blue until you finally find it and declares a winner. Okay, declares a winner. Cool. So that's what we're going to be diving into today. That was like a very, very fast 10-minute TLDR of everything that we're going to be covering. And I want to stop really quick for you guys to ask some questions. So is anyone completely lost so far? Give me like thumbs. Usually I ask for thumbs up, thumbs down. We're in a lecture hall, but can't do that over Zoom. So if you have questions, let me know how you guys thinking. Anybody confused so far? No? People following along? Good. Give me a thumbs up. I can't see any of the thumbs up, can I? I'm like in a slide. All right, whatever. I'm just gonna take the sample of the 6 videos that I can see and use that as my guide. All right, cool. So let's kind of dive into it. It's gonna be a fun workshop. So let's build it together. If you guys go to weblab.to/color-hunt, you're gonna clone a brand new Git repository. Now, before anybody starts cloning, I wanna make sure that you guys don't clone into your capbook repository, okay? Because this happens way too much. So if your terminal says cat book, you're in the wrong place. So cd space dot dot to get out of cat book first. All right, get out of cat book, and then you can clone your repository. Because if you clone it within cat book, staff is going to get mad at me. We're not going to be able to sponsor next year. It's not going to be fun. So don't clone inside cat book. All right. So and then I'll also do this with you guys, so that so I'm going to type in weblab.to/color hunt. Right. Cool. Very nice. You can see that I just finished the starter 35 minutes ago. That's a good time. All right, so we're gonna click code, and then we have a URL here. We're gonna click that copy button, right? And then let's see. Then I will example clone this. So I'm gonna make sure that I'm not in catbook, all right? And then I'm gonna type git space clone, and then paste that URL. Cool. All right, and then now I can cd into color. Cool. And now I have a bunch of stuff. Okay. Cool. So give that a go. Give you guys a little bit of time to do that. If you need help, ask them the questions talk, I guess. Remote school is pretty hard, isn't it? Like when we were doing WebLab last year, people could just run around and help, but can't do that over Zoom, unfortunately. Okay. Can you guys see this okay? Yeah. Okay. All right, and then once you're done with that, you guys can git checkout starter, and then do basically the same thing you guys did with catbook, right? It's npm install, and then you're gonna want to run npm run hotloader, and then a tab do npm start. Cool. I'll give you guys like a minute or so to do that. And then once you're done with that, throw me a thumbs up, and I'll try to see who's not done yet. All right, so just a little bit more. If you're having trouble with that, make sure to ask staff. And then if you run this correctly, you should go to localhost 5000, just like we do in whatever, your catbook or your React skeleton, and open up the app, and you should see it running. Now, quick to note, I did build this thing off of the React skeleton that staff has so wonderfully provided you guys. So if you want to kind of take a look at it and then build off of it, that's fine as well. But it's not a very aesthetic game, so. Okay. So as you guys are finishing up that, we're gonna, before we start to get to coding, I'm gonna kind of walk through what this structure of everything looks like so far, so we're all kind of on the same page, right? And you guys can keep cloning in the background if you're still working on that. So here's what we have. Here's some context for what's going on behind the scenes here. This might look kind of familiar to you guys, right? The client socket, server socket stuff. You guys just learned socket today, is that correct? This morning, yeah. So we're still kind of getting used to it, but essentially the client socket is the socket port on the client side. The server socket is the socket port on the server side. They're kind of like bus stations, right? And then you send messages across these two. And then you can see that in React land, we have a skeleton, which is just the default name for the base component. I haven't changed that. And also we've added 2 more components. This game component, this login component. Now login, as its name suggests, will handle everything to do with logging in, and the game component will handle all like the kind of game updating, the game rendering, things like that. Okay. And now we're going to add a few more things in here. The first is a canvas manager. So we spent a good amount of spiel talking about canvas earlier. Canvas manager, its only job is to just draw things to the canvas, right? So you have something to draw, canvas manager will draw it for you. And we have a file called input.js, and input.js is just in charge of keystrokes. So like, typing and stuff, if you ever use your arrow keys, input will know, right? So this is a file that I've written for you guys that kind of takes in input from the user. And then finally, we have a file called logic.js. Logic.js is on the server, and that handles running all of your game logic, right? So everything from, the actual internals of the state to like what happens when people move, et cetera, et cetera. So all your logic should go in there. Right? So that's kind of the architecture here. You can see that what happens when you send a input. So if somebody decides to push their arrow keys, what will happen is input.js will catch that, send it to client socket. Client socket will be like, great, it's a new input, and send a socket message from the client to the server. Then the server will say like, oh, this is a socket message that has to do with the game, so I'm going to let logic.js handle it. Logic will take care of that movement and stuff, and then it'll send back some new state, right? Some new state. So you can see there's like a division of labor here. So logic takes care of keeping track of all the state updates that are happening and all like the movement that's happening, et cetera. And then input will take care of actually getting the input from the user and sending it up to the server to handle. Now I'll mention that this state, this game state that I'm talking about, it's very distinct from this React state that you guys have been learning about, right? So React state is what we use to update the React DOM. Game state lives on the server. It's kind of like whatever you define it to be. It has nothing to do with React. It's just something that we're calling what's going on currently inside the game and what we're sending back to people, right? Right. So everybody should have the same version of game state. Cool. All right. So you might ask, like, okay, Alex, this is great. There's division of labor here. So people are, adding inputs, and that's changing the game state, and the server is updating that game state. But then how does everybody, like every single person who's playing my game, know what the current game state is, right? So, what is going on inside the game? Well, what we actually do is inside of our code, and this is not, you guys don't have to write this, I've taken care of this for you, is we just spam the client with game updates all the time. So 60 times per second, you're just sending the game update to the client. You're like, here's a game update, here's a game update. Even if it's the same, you just blast them with game updates. And this is just the simplest way to do that, right? Because you don't have to ever worry about your client being out of sync, because 60 times per second, it's getting updates and updating itself accordingly, okay? So that's how we're gonna deal with this for now. It's kind of inefficient, but more to come on that. So what this looks like in our new model is 60 times per second, you're just throwing updates back at the client, right? Cool. So now you gotta ask yourselves, okay, so we have this idea of a game state, we have input. So what should be in this game state? So I've put together kind of this little fun multiple choice question here for you guys to look at. So what do you guys think should be in the game state, right? Out of all these things. And remember, the game state is kind of like, what does everybody need to know about what's going on in the game? Right? What does everybody need to know? So what do you guys think? Vote now in the chat. I don't know. Yeah, you guys are totally right. And this is one of those questions that professors put on to like make sure everybody's listening. But yeah, like it's the all the above, right? It's the classic, didn't want to make too many complicated options, so just made an all the above. So yeah, it's all of these things, right? Everybody needs to know the color of the player, the locations, and whether anybody won. So in a second, what we're gonna do is we're gonna spend some time to code this up, okay? Cool. All right, any questions so far on this setup? Because I think we're almost ready to get started on our game. We're almost ready. Any questions? And staff, if there's anybody who's asking pertinent questions in the question doc, you feel free to send them to me on Zoom as well. Okay. All right. So let's get started. Where is my VS Code? My VS Code is over here. So everybody's going to open up VS Code and open up this project in it, and we'll get started with the coding. So the first thing that I want you guys to do is go ahead and you guys can all see my screen, right? Yeah. Is this too small, too big for everybody? Is this good? Good size? Can everybody see it? It's tiny. Okay. Good. Oh, that's a contradictory statement. All right, I'm gonna make it a little bit bigger. All right, cool. All right, so let's see what's up here. All right, so what we're gonna do, and by the way, guys, it's completely optional for you to follow along this workshop. If you prefer just to listen to me, please do that. In fact, I might encourage it because there's a lot of coding that needs to be going on. Can I get a link to your slides? Yeah, of course you can. Let's see. Where are my slides? Where are my slides? Over here. I'm gonna send out slides on the Zoom. Cool. All right, so let's take a look. So first thing we're gonna do is everybody's gonna type Control or Command P, and then type logic.js. All right, you guys remember logic.js, our old friend, right? So what does logic.js do? It keeps track of all the game logic, all the game state, everything goes in here, right? So this is like probably the most important part of our game, okay? And the first thing we're gonna do is we're gonna initialize this game state here, this game state, right? So what goes into the game state? Well, we just decided, right? We just decided there are a few things that go into the game state. So first is whether there's a winner, right? And I'm just gonna call this winner. You guys can call it whatever you want, but I'm gonna call it winner. And we're gonna set this field to null because at the beginning of the game, nobody's won yet, right? Everybody's kind of just still in the lost stage. And then we want to keep track of every single one of our players, right? And I'm going to make this a JavaScript object. I'm gonna make it a JavaScript object, okay? And so what this is gonna be is it's gonna be ID to color to an object with color. So we're gonna have color, and then we're gonna have X and Y. We're gonna have color X and Y. So that's all we need to know about every individual player. So when you guys make your games, it's very likely that you'll need to do something like this, where you have a players dictionary somewhere or object, right? Keeps track of where everybody is. Cool. Wouldn't it be an array of objects? Yeah, that's a good question. So instead of an array of objects, we want to keep it an object of objects so that we can have like a key to value mapping. So now we can access, like, those of you that are my 6 presentation, you know this, like you want to O of 1 access, right? So if it was an array, you have to like iterate through every one. That's annoying. So we prefer to have it be an object in this case, right? So now that we have this, the next question is, okay, when are we going to update this? When are we going to update this game state? Okay, so what actions? Let's brainstorm together, guys. Let's take a second to think. When do you guys want to update this game state? Like, what actions are going to happen on the front end to make you update this game state on the server? Any ideas? Any ideas? Yeah, keys pressed, good. Keys pressed, someone wins, very good. So any kind of movement, right? And new player joins, good. New player joins, good. Right, so all this stuff. There's one more that we're missing. One more that we're missing is actually when a player disconnects too. Because if a player disconnects, you want to boot them out of your game state. Otherwise, you're going to have like ghosts floating around. And this is generally not a good thing, right? So first thing I'm going to do is I'm going to show you guys how this is done by us. Let me watch my slides. Where are my slides? There's. So in here, this is a file under server socket. Don't go looking for it. It's fine. You don't ever need to look at this ever again. But inside server object, this server socket, there's a function called add user. Add user. And this is what happens when a socket like connects to the server. And in our code, we've added logic.addPlayer in here. That makes sense, right? So every time a new socket connects, we're going to call this add player function in our logic that will update our game state. So what does that mean concretely for us? That means we have to implement this add player function, right? So how are we going to implement add player? Well, so glad you asked. So what should happen when a player gets added? Well, you want to update your game state, right? So game state.players of this ID we're first going to give it a random location. And I've written a function for you guys that will get a random location from that. Okay, so just grabs a random location. So what this does, it says, hey, I'm going to grab a new player, and then I'm going to give it some random location anywhere on the map, right? Anywhere on the map. And then I'm also going to give it its color. Dot color, right? And then I've also written another function called get player color. Now, I know, I'm kind of just like glossing over all these things, but you guys can go look at it after the workshop. Unfortunately, we only have an hour, so I don't have time to get super into the depths of how we're updating these locations and colors, but I've written the utility functions here, right? So essentially what we're doing is we're getting a random location and then updating that color to make it work, okay? Cool. So what this does is it just adds a new player, right? So now whenever a new player comes in, they should be able to, get a random position, location, and a random color. And then we also want to be able to remove players, right? Same kind of logic here, but instead of, we want to change the game state, right? So how are we going to change the game state? Well, we can just delete game state dot players ID. Right? So what that does is it's just going to take that ID and just punt it out of the object. You're no longer in here, right? Because we don't want any IDs who are no longer connected to our socket to be in our game state. Cool. All right. So I'll give you guys a second to process that. So we've just added the player and removed the player. Okay. So now the next thing we're going to do is we have our game state and it's on the server and things are great, right? So players are getting added, players are getting deleted, everything's awesome. But right now our canvas isn't drawing anything, right? So our game is not playable if our canvas isn't drawing. So what we're going to do now is we'll go press Control or Command P and go to game.js. Game.js. Right. And you can see here that I've written a function called socket.update. This dot process update. So what that's doing is every time you get an update from the game server, we're gonna update our game state somehow. We're gonna update that, right? So how do we do that? Instead, in here, we're gonna call a function called draw canvas update. And draw canvas is a function that we're going to define in 1 second. Okay, so we're kind of working forwards here. So draw canvas hasn't been implemented yet, but we're going to implement it in just a second. And what draw canvas does is it's a function in Canvas Manager. Okay, so we're in game.js. We have draw canvas and process update. We go to Canvas Manager. Actually, we'll go back. So Command or Control P, Canvas Manager. And you can see we have a function here called draw canvas. Right? We have a function here called draw canvas. And what draw canvas is going to do is, well, it needs to draw the players and where they currently are, right? That's the main kind of meat of our game, is where all the players are, right? So when we're drawing all the players, we do, and I'm going to type this out and I'll explain it in a second, so don't get too overwhelmed. Okay, we're going to do object.values of our state. And then for each one, I know this is a lot. I wish I had a buka to explain all this, but unfortunately I don't. So I'm going to type all this really fast, and then I'll explain what it's doing in a second. Okay, so this is a lot of code, but what does it do? What does this do? So object.values draw state players is it takes the draw state and the players inside that draw state. Remember, in our logic, we have an object called players, right? So that's just accessing that players object. And it's saying for every single player that you have under that object, we're going to do the following. We're going to draw it. Right? And how we're going to draw it? We're going to call a function called draw player on the X value, the Y value, and its color. Does that make sense, everybody? Yeah? Make sense? So this is just kind of a bunch of syntactic sugar for saying, iterate through all the players, draw each one. So now we actually need to implement the actual draw itself, right? We need the actual draw itself. So what I've done is I've implemented a function called fill circle for you guys. And what this does is it takes in an X, a Y, a radius, and a color. and then it'll draw that. It'll draw that. Okay. But here's our problem. Remember earlier when we were talking about this whole like canvas versus like real life nonsense, right? So our problem right now is that we're drawing in real life coordinates, but we actually need to convert it to canvas coordinates first, right? And Juliana asked a great question that I'll get to in a second. So what we're going to do is we're going to create two variables called draw x, draw y, and we're going to call a function called convert chord. Very creative, which converts the coordinates from real life coordinates over to canvas coordinates, and then fill the circle using canvas coordinates. Because remember that earlier diagram we had where canvas is like the zero is the top left, but in real life it's in the middle, right? That just makes that conversion. All right, so let's talk about context. What's context? Context is just like a property of this canvas element. Remember, canvas elements are just HTML elements, right? So they're just like kind of like a div, but more fancy. Whenever you want to draw something on a canvas, you need to pass in the context, because the context is the object on which it's drawing stuff. It's like a good way to think about it, right? And you can read more about the documentation of this later, but essentially every time you want to draw stuff, you need to use the context to draw it. So we need to pass it around everywhere, and it's kind of clunky. Okay, cool. That was a lot of what we're doing today, is just this one pipeline of logic and then game and canvas, right? You guys see the kind of thing here. If you guys only gonna take this is the most important part of this lecture and workshop, is you have kind of many sections, and each has its own realm. So logic deals with logic, it sends that down to game, and then game calls canvas, which draws everything, right? So every file has its own responsibilities, and as long as we keep these files separate and keep them doing what they're supposed to be doing, you're golden. You're golden, right? Cool. All right. So let's see if I made any typos. I think, right. So let's try this thing. So if I go to localhost 5000 and I log in, and I'm using the cat book auth because I was lazy. Let's see. There we go. Now you have your player here, right? And you can't do anything with it yet. All it does is it draws the player. But honestly, this is most of the work, right? Now you've set up these three sections of logic, and then the actual React stuff, plus the canvas, and everything else is just filling in the blanks. Just filling in the blanks, right? So when you're designing a game, this is the kind of setup you want to have, logic and canvas, right? But yeah, we've been able to draw a circle so far. So great work, team. All right, I'm gonna take a quick pause for questions, because I know we just went through a lot. How's everybody feeling? Okay so far? Yeah. Everybody who wants to build a game is like, I'm ready. Let me go, Alex. I'm gonna go do it right now. I'm ready to build Among Us right now using circles. Cool. No questions so far. Everybody following along okay? Yeah. All right. So great. So if you guys want to catch up, we're gonna do where's our slides? Over here. So you can get reset hard, and then check out step 1 if you want to catch up to where I am right now. Cool. Get reset hard, and then check out step 1, and then we will keep going. We'll keep going. All right, we're doing okay on time. Good work, team. Alrighty. So I'm gonna go back into VS Code, and we're gonna work on the next thing. So next step. All right. So we have everything spawning. There's stuff that's drawing, and your guys are like, Alex, I'm tired of hearing about logic and canvas, but you guys are gonna keep hearing about it, right? Now we're gonna start dealing with movement, right? And I have a file called input.js that you guys can go look at after this workshop, which deals with all the keystrokes and stuff. We're not going to touch that file right now because it's not going to fit within the hour. Okay, but what I'm going to have you guys do is trust that eventually what happens is the logic gets to here, this move player function inside of logic, right? So what happens under the hood here is when you press a keystroke, input.js catches that, right? It catches it, and then it sends it to the server, and the server is like, whoa, it's a movement. What do I do with the movement? And you're like, wait, Alex taught me that I should put it in logic, right? So then we wrote a function inside logic.js which handles moving players. And what should this do? It should update the game state, right? Because once we update the game state, everybody else knows about it. So how do we do that? How do we do that? And you can see that it passes in a direction, up, down, left, or right. So if our direction is up, right? If our direction is up, what do you guys think should happen? What do you guys think should happen, right? So, oh, I see some of you ask questions. I'll answer these in a second. So yeah, so if you're gonna go up, how are we gonna access this particular player that we want and change their position, right? What do you guys think? What do you guys think? Right, so y should definitely change, right? Remember, when you're in your logic, it's not in canvas coordinates, it's in normal coordinates. That's why we have all that convert chord nonsense, right? So up is actually y increasing, right? Because you want 0, 0 to be the center, right? You guys can define it other ways, but this is usually the most intuitive way, is like up means y goes up, right? So that means we want to do game state dot players of ID. Actually, let's make this a little bit easier, and we just do, we're first going to get our player, which is, it's just game state dot players of ID, right? Can't type. So what that's doing is it's just getting the object that is our player, and then we're going to say player dot y plus equals 20, right? Plus equals 20. So what that's saying is, hey, in the game state, let's find this particular player that you're trying to move and change their y by 20. That's all you need to do to move, right? It's because we have this really nice setup here of logic and canvas. Right? Okay, so let me look at some of these questions. How do you pass position to the client? Right, so the position and the game state in general is emitted to the client all the time, right? 60 times per second using the socket. So the client is always aware of these position updates. HTML5 graphics only apply to browser games, right? Yeah, exactly. So things like StarCraft, Fortnite, all this stuff, they use much more advanced things. Canvas is like a simple in-browser solution. Yes, so since we're converting on the React side from normal coordinates to canvas coordinates, we can deal with like normal coordinates here. I like to do that because logic can get really complicated and you don't have to think about like, canvas coordinates are this way, right? So you just deal with it when you're drawing. That's the easiest way. So let's fill in everything else. And some of you guys might already started doing this, but you know, if dir equals down, like what's up, right? Well, player.y, you probably want to take away 20. I don't know, I chose 20. What do you guys want to do? You guys want to do 20? I feel like 20 is easiest, so I've just been doing 20. And then if it's left, what happens? What do you guys think? What should go here if you're moving left? Vote now in the chat. Yeah, good job. So player.x minus, look at you guys. You guys are game experts already. Don't even need to teach you guys over Zoom. All right. Oh, I don't know how to type. All right. Right. And then we're gonna add on 20. And that's it. That's literally it, right? So you guys see how simple games are once you just say, all I'm doing is I'm updating the game state, right? So if we go over, let's see how good my coding is. See how this went. And look at that, we can move, right? So you guys should be able to move in your own games as well, which is pretty sweet, right? Cool. Cool. All right. You said this, but how do you make sure a player doesn't go off the grid? That's a great question. You don't in our game. Right? So players can go wherever they want in our game. It's great. But the great thing about this is that you guys, the game designers, can do whatever you want. Do you want players to be able to go off the grid? If so, then don't worry about it. If you don't want them to go off the grid, right, you probably want to check in move player if they're going off the grid. And if they're going off the grid, you're like, no, stop, right? Because this is logic. So all logic should go under logic.js. It's a great question. Great. So now we've managed to make everybody move. That's pretty sick. So now we just need to change the colors. And what we can do here is we can do the exact same thing that we used to do, which is that player.color equals get player color, right? Which is how we did the initial the original initialization of the color. We're just re-changing it now to update whenever we move, right? Because every time you move, your color is going to change. Your color is going to change. Yeah, exactly. So to answer the question about how do we check if chords are off the board, you can just check inside logic.js, right? Cool. Alrighty, so let's see how our game is doing. Hit that nice refresh button. Go log in using Catbook because I'm lazy. And look at that, your color is changing. Oh, so pretty. So pretty. All right, this is a complete web lab project. I'm turning this in for credit. Cool. All right, so that's nice. Great. All right, so you will fail the class. That's very mean. Nick, you are so mean to me. All right. All right, let's move on. So if you want to catch up to where we are, okay, you could check out step 2. All right, cool. We're doing great on time. So anybody have any other questions? You guys basically built the game already, right? Come on. You have circles and they're moving around. What else do you want out of the game? Cool. So go ahead and check it out. No personalization. Yeah, I guess that's true. Cool. All right. So let's do the next thing. So we're almost done, guys. Honestly, we're almost done. You guys have been doing a great job. So the next and last kind of thing that we need to do is there's currently no win state, right? There's no way to win. How's that going to work? Right. So we need to actually be able to check whether somebody is going to be able to win or not. Right. So how are we going to do that? How do we do that? Well, handily enough, I have a function called check win. Right. And what check win should do is we want to figure out whether anybody has won or not. So how do you guys figure out if somebody has won? Let me know in the chat. How do you know if somebody has won? What is our definition of winning in this game? Do you guys remember? We talked about it earlier. Yeah, their location is the goal. Exactly. Yeah, you can either check the color or the location. Checking the color is actually an interesting idea. So if you're entirely blue, then I guess you win. That's a good also a good approximation. But yeah, I think the most straightforward way is like, look, let's just check if they are on the goal, right? And handily enough, we have a function, we have a thing up here called const goal equals get random location, right? So we can just check under logic.js whether or not you hit that goal. So let's do that. So I'm going to do some funky nonsense here with object again. So object.keys. What does object.keys do? It just iterates through the keys of the object. So all the IDs of each player, right? So what this is going to do is it's going to output a list of all the players. And then for each one of those, for each like ID, I guess, I'm going to call it, yeah, we can just call it the ID, right? What do we want to do? Well, first, let's get the player out, right? So const player equals game state players of ID. Right. Okay, so what we've done here is we're literally just iterating through every single player because that's how we're going to check if anybody hit the goal. And we get that player. And if we say if player.x equals the goal and player.y equals the goal, right? Then what do we do? What do we do? How do you guys want to update the game state? Any thoughts? Remember, our game state looks like this. Right. So this. Yeah, good job, guys. Excellent. Yay. Yeah, so we're gonna set the winner, right? We're gonna set the winner. Yeah, so inside this function, we say excellent. We say game state dot winner equals this ID. Because that's the person who won. If they're on top of the goal, they've won. Now, here is a really important point. If this logic lives on the client, like lived on your browsers, right? Each one of your browsers, and everybody could check the winner. You could just win by changing this code on your client, changing that logic, and then you would automatically win, right? So you could just like straight hack it if you want, like a hacker man, right? Oh, so cool, right? But no, it's the developer's fault for putting game logic on the client. That's why we don't do that. We don't do that, right? This is why it's so important that your logic is on the server. Cool, so now we have a winner, which is pretty sweet, but we need to check when we're winning, right? So when do we need to check win? That sounded weird. At what time do we need to check win? Like what could change to change a winner, right? So how often do you guys want to check win? Yeah, so there's a few proposals here, right? And you could do either one. You could either check every frame. So you could just be like, I'm constantly gonna check for winners all the time, right? But if you think about it, the only time anybody ever is gonna win is when somebody moves, right? So we can actually just do it in here. In move player, right? Because if that player moves, we can just check the win. We can just check a win, right? Does that make sense, everybody? So two ways. I think the more performant way is just to check every time somebody moves, right? And then you're almost done. You're almost done. So now you have a winner in the state, right? So the logic part is taken care of. So what's left? If we've already finished the logic part, right? What else do we have to do? Last part of this game. Yeah, that's right. That's right. So we need a display on the client, right? As Daniel said in the chat, right? Excellent. So we need to somehow show the winner. And I've already done a lot of that for you. So we're going to Command or Control P, game.js. Okay, game.js. And you can see here that process update is kind of the pipe in which all updates flow, right? So what we can do in here is we can say, if we got a winner, from the client, right, we can this dot set state your winner to update dot winner. So what this does is it tells React like, hey, if you got a new winner in the update, so somebody won the game, you should tell everybody, right? You should tell the client that somebody won. So we set the state here. That makes sense, everybody? Okay. Cool. So let's give you guys a second for that. Nice. All right. So once that's all through, let's see what we're looking at, shall we? So we go back to our coolest game ever. Go ahead and log in, right? And nothing happened. What's going on here? Is our client broken? Cannot convert undefined. Oh, wait, yeah, okay. We need to restart. So we made a typo. That's excellent. So go back to logic.js. I think this should be gamestate.players. Yeah. I don't know how to type clearly. This used to say gamestate.player. All right, now let's try again. Let's try again, see if this works. If that works, yay. Okay, so where is this thing? I'm really bad at my own game, by the way. Somewhere around here? Somewhere over here? I don't know. No? All right, I don't know. I'm bad at this. Oh, there we go. Okay. All right. Great, cool. So we found our secret square, right? And you guys can too on your own computers. And the great thing is this supports as many users as you want, right? So anybody can connect to your game and you guys can all play this color hunt game together. Excellent. Great work, team. All right. Get good. All right, what do we have in the chat? What if you never hit the goal? Right, so you have to account for this in your game logic. So what the question is like, what if we're ever jumping by 15 or something like that and you can never hit the goal? Yeah, so you need to account for this in your game logic, right? So a few ways you could do it. You could either be like, okay, if I'm close enough to the goal, somebody wins, right? Like maybe I'm within 20 from the goal. Or you could be like, hey, I'm only gonna jump in increments of 20, and then I'm only gonna set the goal at increments of 20, and then you're also good. I think we went with the latter in this approach. Right now we're updating at 6 times a second. Is it possible to update at 6 times per second only when someone's keys are pressed? Yeah, you can do that. So a lot of this game is by far and large not great that good of a game, right? It's not terribly fun, and we're doing a lot of things like constantly spamming updates that we don't necessarily need to do, but it does give you guys a starting point to start out on how to set up this logic, right? And as Nick said, it's lots of work, right, to actually do this the right way. All right, cool. So if you want to come to where we are now, you can get checkout main, get reset hard, and get checkout main, and you should be with us at the completion of the game. All right, so that's the completion of the workshop. You guys did great. We blasted through it, finished developing a game within 40 minutes. Pretty fast stuff. So proud of you guys. I'm excited to see all of y'all's games. So what did we learn today? Let's take a really quick recap and kind of go over our thoughts here, right? First things first, game logic, where does it live? I'll give you a hint. It's not on the client. All right, so game logic always lives on the server. All right, so if I see anybody's games that has game logic on the client during judging, I'm auto failing you. No, I'm just kidding. I will not auto fail you, but I'll be very sad. So game logic always goes on the server, and we'd like different technologies to draw this game. Like you can do it through React, but generally like Canvas or something else is a better choice. Okay. So great work today, everybody. It was great to come in. I'll give you guys like a 2-minute spiel on Gather, and also send the jobs board out to you guys. So Gather, right now we're a startup that's, I mean, you guys know what we do because you guys used our product for milestone 1, but we're actively hiring for software engineers, product managers, all kinds of roles. And as we're also thinking of starting an intern program, but we're not 100% sure yet. But anyways, come chat with us and feel free to come learn more if you'd like. And I will send out the jobs board on the chat. How do I stop screen sharing? Oh, here we go. Cool. And yeah, if you guys have any questions about anything, I'd be happy to answer them, whether it's related about the workshop we did or the work we do at Gather. And I will send out the jobs board momentarily. Here's our jobs board, by the way. I think, oops, I sent that to Claire. I don't know if Nico, you guys have a place you guys are putting jobs boards for sponsors, but feel free to throw ours up there if you'd like. Great. So that's about it. Does anybody have any questions or anything about the workshop? Ah, put on Piazza. Thanks. That'd be great. Cool. I guess I just did a really good job of explaining everything, and everybody just completely understands, and there's just no holes in the comprehension. I dig that. I dig it. I dig it. How do we start the game? Yeah, so our current game is set up so that if you find the goal once, you can't unset the winner. So now you have to restart your server, which of course is not ideal for a game. So we're gonna have to find some way that you like add some user interface element, right? That that you click, and then that should reset the winner, reset the goal, or whatever, and then you guys can go find the goal again. How do you handle lag connections? Yeah, that's a great question. So right now in our game, we have no handling of lagging connections, right? Like everything, if you just lag, you'll just be disconnected from the server and you won't get any updates and you won't get any like anything at all, right? How games deal with this is, how a lot of games deal with this is they do like client-side prediction. So like predict where the player is going. So even if you're gonna be lagging a little bit, at least the client will be like, oh, this person was moving this way, so they'll probably continue to move that way, right? And then how do you add players to see your same game? Right. So once you deploy this, it's like Chatbook, right? It's exactly the same as Chatbook. You can open 2 tabs on your localhost, like one in Firefox, one in Chrome, and play against yourself if you like. But in the future, when you guys build out your games, you can just create a website for it, and everybody can come into the same game and it'll work. How did you decide to start? Oh, Jason asked like rollback. I'm not sure exactly what rollback is, but maybe, if I'm understanding what that is. How did you decide to start GatherTown? Okay, so before I get into that, we have an engineer and somebody early at GatherTown here. Her name's Amy. Amy, where are you at? Are you around?
Oh,
Hi. So Amy also works with me at Gather, so I had her come as well in case you guys had other questions. Nico, how do you want to do this? Should we like set up 2 breakout rooms for questions, or do you want to kind of just do it all in one? Like whatever you guys want to do.
You can do it here if you want. I don't know if Claire or Kai have an opinion. We just moved to the breakout room so that way you could give your lecture here, but
Okay,
you can
yeah,
do it
sure.
here if you want.
Yeah, so I can answer how we decided to start Gather. We started Gather right when quarantine started. And in the beginning, it was kind of just a fun project that a bunch of friends put together. You know, I staffed Web Lab for a while, so you guys know that I like building fun things like web projects. And we kind of just threw it together, and then people seemed to really like it, and it started making enough to justify bringing it into an actual business. So that's what we did. So it was never intended to be like a huge business or anything. It was more like a fun thing for us to try running around a virtual world. And I guess it's stuck on ever since. So we're very lucky to have had that. Yeah. How was it like when you created it? Yeah, I guess similar question. Yeah, it's been pretty fun. It's been a lot of learning. Lots of janky code, as Shannon knows. Shannon was also working with us for a while. So. Do you guys have other questions? Okay, let's see. So let's go through this one at a time. If Logic should be on the server, how does Google No Internet Dinosaur game work? Yeah, so Google Internet Dinosaur game is a 1-player game. So if it's a 1-player game, then whatever. But actually, the Google Internet Dinosaur game is really easy to cheat. Like you could very easily cheat on the dinosaur game. You probably give yourself infinite points if you wanted to, because all the code is like client side, right? So that's kind of the answer. If you want multiplayer games that prevent cheating, you need to have it on the server. What was the hardest thing to code and gather? I'll let Amy answer that. What's the hardest thing you worked on, Amy?
I guess working. So we are working on this desktop app for Gather. There are a few parts of it that were, I guess, like tricky with like audio video stuff and making sure that I guess there's like this mini window thing that pops up when you're on desktop apps. So you kind of feel like you're persistently in a space and can always see a preview of what's going on around you. And so there are some tricky things that are going on there with like videos muting or like audio muting unexpectedly and then having to debug that. I think it's always just like debugging that's challenging, but also fun once you like kind of discover or like figure out what's going on in the what's going wrong. Yeah. Alex, what was like the hardest for you?
Probably performance.
True, yeah.
As you guys can tell from our workshop today, like our workshop is very not performant. Let me tell you, like, you're blasting updates to the client 60 times per second. It's like very bad, right? I think Gather sends 20 updates per second instead of 60 or 24, I think. But we do a ton of stuff on the client to make sure that you're not doing extra work. So for instance, you can, if the update hasn't changed, we literally do nothing. So you like check if the update changed anything, and you're like, okay, if it changed nothing, then let's not do anything. And we have a system where it sends like diffs instead of the whole state so that, it doesn't blast the client. All kinds of problems like this are really hard to deal with. Why can't Gather handle screen sharing to 200 students? I don't know. I'm not on the info team. Don't ask me. No, my understanding of the video code is that it's just like too much bandwidth for one DigitalOcean droplet to handle. So it's not able to be done right now. Zoom is crazy, by the way. You guys, Zoom is insane. Zoom stitches all the videos together in the back end, like on their servers, and then sends it to you as one stream. Instead of sending you like 100 streams, it sends you one stream. It's crazy. Some crazy stuff they're doing on Zoom. It's completely nuts. Have you ever considered building Among Us and Gather? Yeah, this is in the works. It's in the works. We don't know when it's going to be out. We're working on a system right now that will let you do build arbitrary games inside of Gather. So it includes like, and this is like not anywhere close to being deployed yet, but we're experimenting with like player-to-player interactions, and then external game servers that allow you to, like, anybody can build a Gather game and then plug their Gather space into their Gather game engine. And then now their Gather game engine handles all the logic for them. And then we literally just render everything for you. So I'm very excited for that. Like Minecraft, exactly. So our vision here is that your Gather spaces should be more customizable than Minecraft spaces. Like, I want you guys, like, we should be able to do pretty much anything in the Gather space. Like, you want to build Among Us, like, go crazy, right? But that's the dream, and I think we have a few folks working on that right now. One of our really interesting problems that we're hoping to get soon. How would you find people to work on Gather with at the beginning of other projects? I mean, I just worked with my friends, I guess, and then Amy, you can take this opportunity to pub Hack Lodge if you want.
Yeah. I guess like all the co-founders were part of this community called Hack Lodge. It's this program where pre-COVID times, we ran like week-long hacker house type of program where we'd bring together like 20 or so undergrads. It ran in like the winter and the summer in various cities, and we would, I guess, like just spend a week hacking on a project in teams. And I also participated in Hack Lodge one summer and started doing like some organization stuff too. And that's how I learned about Gather too at the start. I remember Philip sent out this email to the mailing list and told us like, oh, they're like, that Gather was looking for people to join and help work on the product. And I was also simultaneously introduced via a mutual friend. So that was also kind of really cool to see circles kind of coming together and being able to meet new people too through this Hack Lodge community. And other than that, do you want to talk about other recruitment efforts?
Yeah, so like Daniel and Akshat were saying, like, Hack Lodge is super cool. If you guys are interested in that, you should reach out to them because it's a super fun experience. And I guess a lot of our, like in the beginning, a lot of it's just working with your friends. I think if you guys want to get a product started, just work with your friends and build something cool, right? Don't worry too much about things in the beginning. Like, I feel like I worried a bunch of stuff in the beginning that just wasn't even relevant at all. Like, you're just gonna build something cool and then, like, you know, just build it for the sake of building it. And then I guess past that point, a lot of it was, you know, very intentional recruiting, reaching out to different communities, reaching out to you guys here at Web Lab to kind of get people who are interested in web projects and beyond. Cool. And of course, you guys are free to go, by the way, if you want. I mean, it's 2:02, so feel free to go. I'll say a closing statement that I'm really excited to see all your guys' games and websites, and I'll try to drop by the hackathon to kind of say hi to y'all because I miss Web Lab. So
yeah, can we get like a virtual applause for Alex and Amy and Gather? Yeah, thanks for joining us. Just a couple of closing announcements. We have a hackathon this Friday. It's not like a competition type hackathon. It's more just like office hours on steroids. So if you're working on your project or if you're stuck on your milestone, definitely come to office hours. And then also subscribe to our YouTube channel so we can start monetizing and go through every single video. And if you like it, we'll give you bonus points at your evaluation. Yeah.
What?
But other than that, I think that's all we have for today. Yeah, thanks everyone.
Thanks everybody. I'm gonna stick around for any other questions you guys have. But you know, feel free to hang out or whatever, and I'll see you guys all at the hackathon if, yeah.
You can't judge our shameless plug, Alex.
Yeah, true. You guys should just plug. All right, take care, guys. I'll see you all at the hackathon.
Yeah, thanks, Alex.
Yeah, of course. If anyone else has any other questions, I'll stick around for a little bit. But you know, feel free to also drop off and do whatever.
Wait, I have a question.
Sure.
Hi, Alex.
Hi.
How are you? Yeah, how is it like creating a startup? Like, was it like how did you start, I guess, like to learn about the business side of things?
That's a great question. I didn't handle too much of the business side. Our CEO did a bunch more of the business side of things. But there's so much to learn about, like, startups are kind of weird, like startup valuations, like raising money, all this kind of stuff we never had any exposure to. So we kind of just stumbled our way through. The biggest advice I have about doing a startup, especially on the business side, if you're an engineer, like you're coming, like all 4 of the founders of Gather are all engineers. So the most important thing is you build an interesting product and then you get advice. So you find people who already know what they're doing inside the industry. For us, this takes the form of a lot of angel investors who want to put in money and like get a small percentage of the company. And they like kind of help us like understand, okay, when should we be raising? How should we raise? All this kind of stuff. And that really helps us kind of, get started. And everybody's journey is a little bit different. So I think most important is talking to a lot of people who already have experience to get a sense there. It's hard to come in with a lot of experience.
I see. Yeah. Wow, that's really cool. Thank you so much.
Yeah, of course. Cool. I'm excited.